All right, here's our second and last video for section 2.3 on formulas. We just got done taking a few formulas and solving them for a different variable. Kind of complicated, so you got to be careful. But look at example number 3. These ones are a little bit harder because it's going to ask us to solve for a variable where there's multiple of that variable. Where in the last couple examples, we only had one y to worry about, or one w, or one t, right? But if you look at example number 3, it gives us an area formula for, it looks like surface area of a cylinder, and it asks us to solve for pi. But if you look really carefully, pi doesn't just show up once. There's two different pi's in this equation. So that looks a little bit different. What we want to do is we want to get down to just one pi, and then we want to get that pi by itself to get our equation to say pi equals, with no other pi's in the equation. So here's what we're going to do. If you notice that both of these terms have pi in them. So what we're going to do is we're going to factor out a pi. I'm going to take a pi out of each of those terms, and then I'm going to leave my leftovers. I'm going to kind of reverse distribute. When I do that, I have my a equals, I'm going to take out a pi. If I take out a pi from the first term, there's a 2 and an r and an h left. When I take out my pi to the second term, there's a 2 and an r squared. Think about distributing this back out. Wouldn't I get back where I started? So that's kind of what we're doing. We're reverse distributing. We're taking the pi out. Now how many pi's do you see? 1, right? Which is perfect. It's better than 2. So now we can try to get that 1 pi all by itself. Now if you notice, there's all of this stuff that's next to the pi, and it's right next to the pi. That means it's multiplied by. So how do you think I can get rid of all that stuff? Well, if it's right next to the pi, that means multiply. So to get rid of all that stuff, that whole chunk, can I divide it? I'm going to divide the whole entire chunk away from that pi so that it reduces off, and then I have pi by itself. I can't put an a with an r with an h or an r squared, so I just have to leave my answer like that. So I end up getting pi equals a over 2 pi h plus 2 pi r. Only one pi, and it's all by itself. All right, maybe you can try B all by yourself. Why don't you try pausing the video and try solving this one for C using the same technique that we did in part A. All right, this one asks us to solve for C. I notice that there's two different C's in this equation, and I can't combine a 3C with a 6CY because it doesn't have the same stuff, right? So they're not like terms. So what I can do is notice that both of these terms have a C in it. So I can factor out a C just like I did in example 3A. When I factor out a C, I still have the D equals. I'm going to take out a C and I'm going to reverse distribute. So if I take out a C from the first term, what's left over there? And if I take out a C from the second term, what's left over there? You should have a 3 plus a 6y. Think about redistributing the C through. Would you get back where you started? We should, right? C times 3 is 3C, and C times 6y is 6CY, so it's perfect, right? And now, how many C's do I have? Just one. Better than 2. That's perfect. All right, but I still want to get C by itself. And again, if you notice, I have a whole bunch of stuff that's right next to the C that I need to get rid of. I have the 3 plus 6y. But that whole chunk is right next to the C, which means that whole chunk is being multiplied. So in order to get rid of the whole chunk, can I do the opposite of multiply and divide both sides by 3 plus 6y, the whole chunk? That reduces this chunk off to the side here, and then I'm just left with the C equals D over 3 plus 6y. None of those are like terms, so I can't combine it, reduce it, or make it look any more simple than it is. And so that would just be my final answer. I've rearranged that problem, and I've solved for C. Kind of tricky, right? So just make sure that you're paying attention to how many variables you have of what you're trying to solve for. If you have two C's, see if you can get them to the same side and factor it out. That'll help a lot.